Hello and welcome to the National Air and Space Museum in Washington, D.C. My name is Marty Kelsey. I host a television show for middle school students from here at the museum. You might have noticed there's a rather large vehicle standing behind me. This is the Mars Concept Rover, 5,500 pounds, 23 feet long, almost 11 feet tall with a top speed of 6 miles an hour. This thing is incredible, and I'm really excited about having it in the museum today. I taught for a long, long time, and we've got a lot of young people standing around waiting for the astronaut to come up, and it's really exciting because these guys who are 10, 11, 12 years old are right in that window for the perfect age to maybe be the first person to step foot on Mars. To me, that's incredibly exciting. It is my honor today to introduce our guest, NASA astronaut John McBride, former naval aviator. He flew on STS-41G, piloted the Space Shuttle Challenger, spent over 8 days in space. Please welcome astronaut John McBride.
Thanks, Marty.
No problem.
Thank you. Let me add my words of welcome to you here at the National Air and Space Museum, one of the most iconic places on the globe. You could spend days in here, and I have literally over the last 30 or 40 years spent days in this beautiful facility. At one time in my life, I was assistant administrator of NASA just across the street when we were in the building right across from us, and got to spend 3 years here in Washington, D.C., and lots of nights were spent over here speaking in the Air and Space Museum. So it's a very special place in my life and my heart. This thing behind me, what a beautiful piece of equipment. In less than 1 year, we sat down, we sat around the table, we came up with a design concept, and this is what you see in less than a year. This is not designed to go to Mars. It won't make the trip. This is a prototype. I'd like to think that it'll go to Mars, but it was not designed with all the space capabilities to leave Earth and travel that 1 year and land on Mars and have people live and work in it. So this is a prototype. It's our best guess. And we used an educated guess. We talked to everybody that we could talk to about what they thought the lunar or Martian rover would look like, what it would act like, what its requirements would be. So what you see behind me is not the one that will make the trip, but I'll guarantee you that a lot of the features that you see here are real and will be a part of the Martian rover that actually makes that trip. It was designed and built by the Visitor Center at the Kennedy Space Center, so there's no tax dollars, by the way, in this thing. It all comes from the proceeds of the gate receipts that we take in down at Kennedy when you come and visit us. So come and see the Kennedy Space Center and see the Martian rover down there with about 2 days more of activities that you can visit and witness at the Kennedy Visitor Complex in Florida. So make sure you do that. It'll be well worth your time. I started off in the great state of West Virginia right next door, born and raised over there, and was a West Virginia mountaineer. Got to go down to Houston in the very first class of Space Shuttle astronauts. All the guys that came before me were those older guys. Look at me now. But back in 1978, when I came aboard in the very first class, the only people who had flown before us were the Mercury, Gemini, and Apollo astronauts. So we were the very first class of people picked and chosen to fly this brand new thing we called Space Shuttle. Not so brand new anymore. They're all retired, and one of them is out at Dulles Airport at the National Air and Space Museum Annex out there. So it's been a wonderful career for me to be in that very first class, and we had 35 of us. There were 15 like myself who are pilots, we're all test pilots, and 10 of us came from the Navy and 5 from the Air Force. The other 20 in my class are a new category of astronauts that NASA had ever had before. They're called mission specialists, including Sally Ride was in my class, our first American woman. Guy Bluford, our first African American, was in my class to fly in space. Ellison Onizuka was our first Japanese American to fly in space. So first mountaineer right here. So it really was a unique group of people that NASA assembled in 1978 to be the first cadre, I say, of astronauts to fly that brand new vehicle called Space Shuttle. And we built 5 space shuttles. The first one we built was called Enterprise. It was on display out at the Air and Space Museum for many years. It's now on the Intrepid up in the Hudson River in New York City. The first shuttle we built to fly in space was called Columbia. And I was very fortunate on the first flight of Columbia to be the little chase pilot that joined high with them over Edwards Air Force Base and made the descent and landing at the dry runway out at Edwards Air Force Base in April of 1981. The first crew to fly the shuttle was John Young and Bob Crippen, two naval aviators just like myself. John Young had walked on the moon, and he was chief of the astronaut office, so obviously he got to be the commander, right? And Bob Crippen was his pilot. So it was only flew 2 people on the first 4 flights of the space shuttle. That's because we wanted to make sure we could get the shuttle up into space safely, fly it around and do all the mission objectives, and come back and make it a landing. So I was there on the first one, and we flew 2 people on the first 4. Then we got a little larger. We flew 4 people. Then we flew 5. Then we flew 6. And I took the first crew of 7 on the 13th flight of the space shuttle. We always wanted to get to 7 people because we felt that was the maximum, most efficient crew size, to have 7 people on board the space shuttle to do all the experiments. 2 of us were pilots. We still needed, NASA thought we still needed pilots, right, to get this thing up there and fly it around and take care of it and bring it back and land it. But the other members of our crews, up to 5, were what we call the mission specialists. And they're the men and women who did all the spacewalks. They launched the satellites. They did all the experimentation in orbit, took all the nice photographs and all that type of stuff. So we needed a good mix and match of talents, so we had pilots and mission specialists on board to do those missions. So I was very proud to have the first crew of 7 with 2 pilots and 5 missions. And we had the Canadian Broadcasting Service there here. Mark Garneau was the very first Canadian to go into space. And alongside him was the first Australian. Any Aussies here today? Paul Scully Power was the very first Australian, and it was my joy to fly with the first Australian and the first Canadian into space. We were the 13th flight of the space shuttle on board the Challenger. We spent 8.5 days in orbit. I don't know if you realize it or not, but we do circle the Earth every 90 minutes in space. Every hour and a half we go completely around the globe. And to do that, you've got to be traveling about 16,000 miles per hour, closer to 17,000 miles per hour, which means I'm traveling over the Earth at about 6 miles every second. Every second I travel 6 miles. I'll travel across the United States in about 12 minutes, across the Atlantic in about 12 minutes, from London to Mumbai in about 12 or 14 minutes. So totally around the Earth every 90. And the beautiful thing that happens is while you're in space circling the Earth in a fixed position, you don't change anything in the shuttle. What's changing as you go around? Earth is rotating underneath us, right? Makes one rotation every day. So as I circle the Earth every 90 minutes, it's turned about 1,500 miles underneath me. So I don't see the same part of the Earth every time I go around it. I see a different part of the Earth that's just turning underneath me as I circle it. So you put all these, for you youngsters, put all these things together. The excitement of an 8-minute launch, where from the time we start our engines on the pad in Kennedy until we're in space, is only 8.5 minutes. From 0 miles per hour to almost 18,000 miles an hour in 8.5 minutes. Then I'm traveling around the Earth every hour and a half. And as I travel around the Earth, a wonderful phenomenon happens. I'm traveling around the Earth between the sun up here and the Earth, so I'm in daylight for 45 minutes. Then I have a sunset. I go behind the Earth into darkness for 45 minutes. Then I have another sunrise, 45 minutes of daylight and sunset. So as I circle the Earth 16 times every 24 hours, I have 16 sunrises and 16 sunsets. And the beauty of the Earth at day and night is spectacular. Obviously, when you're daytime, you can see all the land masses, all the continents. When I'm flying down the middle of the Mississippi, I can look west and see California and the Pacific. I can look east and see New York and the Atlantic, and the Gulf of Mexico straight ahead. So you can see essentially 1,500 miles in all directions. At night, it's a panoramic view of a different nature, because when you're on the backside of the Earth, you can't see the sun, you're in darkness, but you can see the outline of all the countries and the shorelines with all the lights of the cities. So when I'm flying over the middle of the United States, I can see all the lights. You can see the Atlantic Ocean because of the definition of the lights along the Atlantic coast. And you can see the Pacific coast by the definition of all the lights in California, Oregon, and New York. When you're east of the Mississippi over this part of the world, You can look down, and everything's lit up in the whole United States except one little dark place right here in the eastern part of and what is that? West Virginia, where I come from. We were proud of that there's not many lights over there. It's still kind of wilderness, and we're very proud of our heritage over there. So, but the bottom line is, anytime you're in space, you're traveling around the Earth at every hour and a half. Get to see different parts of the Earth each and every time you go around because you're not covering the same ground. But more importantly, you're doing some great science, research, studying the Earth, studying the universe, launching things like the Hubble telescope, which are finding new things each and every day about this universe that we live in. So you put all those things together, it's probably the best job that a person could ever experience. And I'm very fortunate, very pleased that I had that opportunity to go into space, to travel around the Earth 133 times, and do some great science while we were there. And it's even more important to come back to Earth and talk to folks like you, and particularly the youngsters. We've got some young people here, and we think that the first man or woman that does walk on Mars, drives this Explorer around the surface of Mars, is somewhere between 8 and 18 years old today. Maybe 6 and 16-year-old if we get the go-ahead. Depends on where we get the money from Congress to decide when we will actually go to the surface of Mars. We haven't made that decision yet. We just talk about it, but until we translate the talk into words, we're not going to actually get there. So if you know any of the congressmen and the senators here in Washington, send them a note. Call them on the telephone. Tell them that you want to get this thing to Mars going off and running. We already got the prototype vehicle that will carry you on the surface of Mars. It's going to be a wonderful trip. It's not like the moon. We can get to the moon in about 2 days and back. To go to Mars, it's going to be more like a year one way. And you can't just take off and go to Mars anytime you want to do that, because we're not in the same orbit around the sun, right? It takes us 365 days to go around the Earth. It takes Mars about 780 days to go around the Earth. So we're not close enough in orbit around the sun to where we can take off and go to Mars any day we want to. It only happens about once every 2 years, I think. So we'll take off, and we take off when Mars and Earth are approaching their nearest proximity. And it's going to take us a year to get to Mars, even when we're at the closest proximity. It's still going to be about 40 million miles away or something like that. We don't have the propulsion system to get there much quicker, so maybe some of the youngsters here can design ion propulsion, thermal propulsion, all these types of things that will expedite our travel to Mars and back. But right now, with current propulsion systems, it's going to take us a year. And you can't just, unless you want to just go over and come back the same day, which we don't want to do that, you'll probably have to spend 1 or 2 years on the surface of Mars to wait for the planets to be realigned so that you can make the voyage back to Earth. So all in all, you're looking at a 2 or 3 year trip. How many of you youngsters want to sign up anyway? I see some hands. I like that. Big people too. So it's going to be a magnificent voyage. Just think how proud your family and your friends would be if you're the first man or woman that walks on Mars. Who's the first man to walk on the moon? Neil Armstrong, right? Everybody remembers that name. He's here in this museum. So just think what it would be like for you, your family, your community, your state to be the first man or woman that actually sets foot on Mars and rides in this vehicle behind me. Couldn't be a greater thing to happen. But to get there, remember some of the things I said. Your most important job is education. Stay in school, fill your head with good stuff, study each and every day, listen to your teachers, your parents, your grandparents like me, your counselors, and the people that love you. Don't listen to the people that don't particularly care about you. Never get involved with drugs. That could mess up your whole life. So if you're willing to work very hard, listen to the good people that love you, study, get a good education, there's no reason why you could not be that man or woman that sets foot on Mars for that very first time. So think about that. I'd love to think that I had the opportunity to talk to you today. If you get that assignment to go to Mars, make sure you call me. They'll find me. Just call the Air and Space Museum. They'll find where I am. and tell them that you got selected to be that first person, and make sure I get an invitation to your launch. If I find out you went to Mars and didn't invite me, it'll break my heart. Don't do that to an old man. So invite me to that launch. So I guess the bottom line is that you really got to apply yourselves, make sure you get that good education, because that will determine not only whether you go down to Houston to train to fly to Mars, but your education will determine how well you can do in your life no matter what it is you choose to do. So don't mess it up. Do it right. Listen to your moms and dads and your grandparents and get that education to form the best party, be the best you can. There's nobody that can stop you from doing anything you want to do. I can't stop you. The only person that can get in your way and stop you from achieving your goals is yourself. So you make those choices to, I firmly believe that if you decide today, one of you youngsters, that you want to be that man or woman on Mars, that you can make it happen. And nobody can stop you if you really want to make it happen. Don't tell me you can't do things. I grew up in a little coal mining town in West Virginia. So if I can do that, you can do that. We've got a few minutes for a couple of quick questions if you'd like to do that. Anybody have any quick questions? Ta-da.
Is the spacesuits kind of like armor, not like it? Are spacesuits like solid? Or
are spacesuits solid?
Like,
Spacesuits are going to be very complicated for a Mars mission. They're probably going to have about 8 or 9 layers of material to protect you, keep you pressurized, keep you heated and cooled, keep your breathing air circulating, circulate a little water to heat you up and cool you down. So that suit is probably going to weigh maybe 300 Earth pounds on Mars. Mars is 1/3 gravity. If you weigh 180 pounds here on Earth, you're going to weigh 60 pounds on Mars. So your spacesuit, even though it may weigh 90 pounds, will feel like it weighs 30 pounds. So it's not as cumbersome. But you need to protect yourself. So that spacesuit will be very thick with a helmet, obviously, to protect you, provide you breathing air. Martian environment is not very friendly. It's a beautiful planet, but it's not very friendly. Most of the atmosphere is very thin, and it's about 97% carbon dioxide. So you can't just jump out of your spacecraft and start breathing and living on the surface of Mars without a suit to protect you, or an environment like we have us behind here, the Martian Rover. So it's going to be quite a trip, and I think it'd be well worth your time to study and prepare to go do it. Anything else?
John, what were you doing before you became an astronaut?
Most of the astronauts, well, traditionally up until our class, were all military pilots, test pilots like myself. I came from the Navy. I was a test pilot in the United States Navy. There were 15 of us who were pilots with all the test pilot background. I foresee maybe in the future of space travel that we may not need as many pilots as we're using today, because most people will be operators. We're not going to need flying capability to launch and land the futuristic spacecraft, so you'll be more of an operator than you will be a pilot.
Tell us about getting the phone call to find out that you had become an astronaut.
That's a good story. Now, NASA had about 8,000 serious candidates that they looked at to be selected for the astronaut program. And then when they got down to the final 8,000, they studied for about a year to thin them down to from 8,000 to 200 that they looked at pretty seriously. And out of that final 200, they would invite 15 or 20 down to the Houston Johnson Space Center for a week-long interview process. They get into your head, into your body. They knew more about me physically and psychologically than I knew about myself.
You want to ask?
So after that 1 week with 10 or 15 people each, out of that final 200, it took about 6 months for NASA to finally say, here they are, here's the 35 out of that final 200. So I felt, good English word is blessed, to have been chosen in that very first class with some super folks. And like I said, that all 35 of us got to fly at least one mission, and most 2 or more. So obviously the selection process that we went through worked pretty well.
Can you tell us what it's like inside this rover?
This rover is very, I bet you don't realize it, but it comes apart. It's 2 pieces. These first front 4 wheels will separate from the back 2 wheels, and that will go out and explore the surface of Mars and bring back Martian samples back to the laboratory, redock back in and join with the laboratory, and then they can transfer the material from the front cockpit to the laboratory. And once they're back together, then they can live in both parts of this Martian rover. So it's in 2 pieces. I don't know whether you realize that or not. So it separates so that you can go out and do the Martian exploration and come back and dock again. There'll be probably 4 people that live and work and eat and sleep inside this vehicle when they're on the surface of Mars.
Do you think that Mars could be habitable if we meddled?
Well, I think Mars is habitable. It's not habitable in the sense that we inhabit Earth, because the environment is much more maligned, because it's, like I say, maybe gets up to the freezing level at the equator in the summertime, but most of the time it's 40 or 50 degrees below zero. So that in itself is a challenge. The atmosphere is 97% carbon dioxide, so you can't just, if you could step out in the heat or the cold, you can't breathe. You could maybe take one big breath, that'd be it. Bye-bye. You've got to have a lot of oxygen, right, to breathe, and there's none on the surface. It's, I think, 1% oxygen in the Martian atmosphere. So you can't live it's not a very friendly planet. So we have to live, when we go outside of this vehicle to do excursions, when we're walking like we did on the moon, you're going to have a suit to protect you and allow you to breathe and keep pressurized while you're outside doing your Martian exploration.
All right, we got it.
Okay.
Is the vehicle air conditioned?
Is the vehicle air conditioned? You can bet. It's going to have a thermostat inside there, just like we had in the space shuttle, just like we had in Apollo, just like you have at your home. So if the commander says, I want to turn down a couple of more degrees, you can turn the knob down. It'll be a little 2 degrees cooler inside this vehicle. If it gets a little cold in there, you might want to turn the thermostat up. But there's going to be a thermostat, maybe 2 of them, one in the front and the back. So you can control the temperature in the front of the vehicle separately from the rear of the vehicle.
We have an online question wanting to know if the vehicle will be assembled on the surface or taken in one piece.
Probably what you see here won't show up on Mars in this condition. Most of the things that we sent to the moon were collapsible, and you took the pieces and folded them out and put them together. So I envision that this thing won't look very much like this as it leaves Earth. When it gets to Mars and lands on the Mars, I think it'll take the crew 1 or 2 days or maybe longer to assemble it into what you see here today, using their pressure suits probably to take the pieces and parts that are this is a very voluminous, we say voluminous vehicle as you see it parked here today. A lot of empty space. We can't afford that on a vehicle to go to Mars, so everything's going to kind of be folded up and compressed and packaged into a way that is minimal volume. You still weigh the same thing, but we want minimal volume. And when you get to Mars, it's going to take a crew, like I say, I don't know exactly how long, to assemble all these pieces and made it look like what you see behind me. But I only envision this thing showing up on Mars looking exactly like you see it here.
All right, we've got another one over here.
Hi, my son asks, either going to space or going back to space, do you have experiences such as jet lag?
When you're going to space and coming back, do you experience jet lag? Not really. The thing you do experience is you have to adjust yourself to a sunrise and a sunset every 45 minutes. We get accustomed to our circadian rhythms. Our sleeping cycle is set here on Earth by sunrise and sunset. So your head senses it's time for the sun to go down, time for the sun to come up. That helps you sleep. But when you're in space, particularly in a space shuttle, you're going around the Earth every 90 minutes and see a sunrise and a sunset. That interferes tremendously with your circadian rhythm. So to help that a little bit, when we're in space in the shuttle, we put blinds over all of our windows when we're trying to sleep. So that no matter whether you're in sunshine or darkness, it's kind of dark inside the spacecraft. And you can maybe get in a darker part of the space shuttle and sleep a little bit better. I like to sleep in the airlock in the space shuttle. It was kind of darker and quieter and cooler in there, and that was my favorite place to sleep. My Canadian friend liked to sleep right in the middle of the middeck, floating from one side to the other. I'd wake up and see his head going by, headed toward that side of the middeck, and back asleep. Maybe 2 hours later, I'd wake up, his head had hit him over there, stopped him, start him in the other direction, and I'd see his feet going by. So he made about 4 trips across the middeck during the 8-hour sleeping period. So a lot of people like to sleep in their middeck, their flight deck chairs up on the flight deck, so you can actually sleep anywhere you want to.
Is there a particular region of Mars that they're considering for the first landing site?
There probably are. We want to kind of stay out of the mountainous areas. Obviously, you don't want to try to land this thing in the mountains. So there are probably 3 or 4. And once again, I think it'll depend on when we leave and the orientation of the 2 planets at that time. So yeah, there's probably, I don't know what they are, but they probably have 8 or 10 or more designated potential landing sites, and they'll probably, as we get closer to launch, finalize that choice.
Did you have a least favorite job when you were in space?
A least favorite job? I don't think there's any least favorite job. I guess if you had to clean up the waste management system, that's our toilet. But we didn't have many problems with that. So if you had a problem with the waste management system, that would probably be the worst one.
Tell us about landing in the space shuttle. What was that like?
Well, landing in the space shuttle, as big and beautiful as it was, when you came back to land, it had no engines for landing. So we were a glider. So when we did our deorbit burn, we came back. We did our deorbit burn, as a matter of fact, over Australia, about 1 hour before landing. So we traveled from Australia to Kennedy in 1 hour, slowing down the whole way. I had no engines. When I decided to come home, I turned my space shuttle around backward and start my jet engines to slow me down. Then I turn around forward and start falling. I fall all the way to Kennedy. For 1 hour, I'm falling back into the atmosphere. And the deeper and deeper I get into the atmosphere, the more and more air molecules I'm hitting, which generate a lot of heat on the bottom of the space shuttle. It gets up to maybe 3,000 degrees on certain parts of the bottom of the shuttle. So we're very concerned about that heat on the outside. We want to keep it all out there. But as I get closer and closer to Kennedy, I'm still a glider. I don't have any engines. I can't go around and try another landing again, so I've got to get it right the very first and only time I do it. So that's why we practice our landings, because we only get one shot. As I come back to Kennedy, I'm about 40,000 feet, 8 miles above Kennedy when I'm overhead. So I manage my energy to make a spiraling glider-like approach to land on one of the runways at the Kennedy Space Center. It takes about 4 minutes to do that from 40,000 feet above the ground to landing. You would not like it. You feel like you're falling out of the sky. My nose is down about 20 degrees as I'm coming in to land the space shuttle, making circles around the Kennedy to make sure I manage my energy perfectly to land on the runway. We can't go around and try it again. So when you come down to make that landing, you got to get it right the very first time. So that's why we practice, just like you'll do with your mathematics.
All right, let's give John McBride a big round of applause.
Thank you very much. Enjoy being with you.
We'd like to thank Kennedy Space Center for bringing the Mars Concept Rover. Thanks for watching.